Hi, section 6.4 is about proving triangles similar by angle. The similarity postulate has two properties. All angles of the two triangles are congruent, and all sides of the triangle are in proportion. And that's the two tests that you have for whether triangles are congruent or not. This is the angle postulate, similarity postulate. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Once again, you need the two angles of one triangle are congruent to two corresponding angles of another triangle are congruent. So we have an example here. Triangle JKL is similar to triangle XYZ. And we know this because angle J is congruent to the corresponding angle X, and angle K is congruent to the corresponding angle Y. So we can say, keeping our vertices in order, triangle JKL is similar to triangle XYZ. So we have some examples. Example number 1, determine whether the triangles are similar. Again, we want to look for two similar angles. If they are, write a similarity statement. So we have the right angles are congruent, so we can say that angle Y is congruent to angle B. And if we have angle C is 37, and we subtract it from 90, which are these two acute, the sum of the two acute angles, we know this is 53. So we have angle X congruent to angle A. So we have triangle XYZ is similar to triangle ABC by the angle similarity postulate. Example 2, we have nested triangles. We have the nested triangles PRQ is nested inside triangle SQT. But we can still look at the angle similarity postulate. Angle PRQ is 44 degrees. Angle R, the corresponding angle RTS, is 44 degrees. Angle Q is congruent to itself by reflexive. So we know that triangle PQR is similar to triangle SQT by the angle similarity postulate. This last example is very interesting, and the reason is because it takes us back to parallel lines and the properties of parallel lines. So we have these two parallel lines. There are little arrows right here, but I'm going to enlarge the arrows so we can really see that these lines are parallel. We know that these vertical angles are congruent because all vertical angles are congruent. So we can say angle EFG is congruent to angle HFJ, because we know all vertical angles are congruent. But when we have parallel lines, we have a whole mess of angles congruent. We have angles EGF and angles FHJ are also congruent because they are alternate interior angles. So we have two angles and corresponding angles of the two triangles are congruent. So we can say that triangle